Welcome back to AquaBanas Yacht Engineering Week. I am Grant Henderson with Burgess Yachts. I'm here today on Fort Lauderdale Beach at Lürssen America's office to talk about hybrid technology with Director of Lürssen America's, Tim Hamilton. Tim, how you doing, bud?
Ben, how are you?
Good to see you.
Glad you guys are here.
Yeah. I thought we could sit down for a few minutes and talk about hybrid technology in Lürssen.
Absolutely, man.
Right, beautiful space that you guys have
Yeah,
here.
I've been
It's
here.
a very cool office.
Yeah. So good of you to come out here on like a
Rainy Monday morning.
Exactly. At least it's
Yeah,
not.
but it's a beautiful
not weekend.
space though.
Yeah, thanks.
It's wonderful.
Appreciate it.
Start talking with the development of hybrid technology. When did it start? The future of it, and just getting into, again, you said earlier that you had started developing this hybrid technology Lürssen had back in 2009. So you can kind of talk about the origin.
Yeah, so I mean, hybrid is a blanket term that is used broadly amongst in our industry and amongst clients. But actually, there's a lot of different variations of hybrid. So back in 2009, we started working on fuel cell technology. But even if you rewind before that, we delivered a yacht called Limitless 20 years ago, and that vessel would be widely considered the world's first hybrid motor yacht.
Okay.
And by hybrid there, what that meant was she was a yacht that didn't just have a diesel engine turning a shaft that turned a propeller, so that's called diesel mechanic, directly attached. She had the first version where there was electric motors actually turning the shaft to a propeller along with diesel engines.
And that was the first of its kind?
That was the first time that's ever been applied to a yacht, 20 years ago.
Yeah.
So, of course, we hear now people talking about hybrid over the last 5 years, 7 years, but it's been around for actually quite some time.
Interesting. Yeah, I did not know that. So let's talk about some of the different forms of hybrid, because like you said, hybrid now, that statement is just kind of more of a blanket, broad, vague term now. So talk about the different types of hybrid technology that you're putting into boats.
Yeah, so hybrid is a blanket term. You have straight diesel mechanic, which is just what you would think of a normal ship, which is a diesel engine turning through a gearbox, a shaft to a propeller. The next step would be what generally speaking would be considered what's called a PTO, PTI. So that's where you have still a diesel generator attached to a gearbox with a shaft to a propeller, but also you have a electric motor also attached to that same gearbox.
Right.
And so that electric motor would be able to take power in or power out, power take in, power take out, that's PTO, PTI. And what that allows you to do is either the main engine, through turning the gearbox, can turn that electric motor and create electricity to power the hotel load of the yacht instead of the generators.
Okay.
Or conversely, you could never even turn on the main engines and just the generators could be running, providing hotel load, and in addition, the excess power can be used to run through that electric motor, the gearbox, and thus turn the shaft and thus turn the propellers without the main engines ever going on. So that's another version of hybrid.
Right.
And then yet the next step is where you have a full electric arrangement, which is where you have main engines attached just to generators.
Okay.
And there's no direct connection between the engine, the mechanical engines, and the propeller. And so just the main engines exist to create electricity, which are run through a switchboard. And then that is run into an electric motor that either that electric motor can turn a shaft, which then turns propellers, or you can have the electric motor directly attached to the propeller like you have like in a pod situation, right? So that'd be the most extreme. And then the last version of that is where we start to take the combustion engines out altogether to create electricity, and we use future technologies to create electricity.
Right.
So then that'd be most extreme.
Right.
And then yet another variance between all of those is you can add batteries and larger battery banks to almost any of those arrangements to be able to supplement the power either from the mains or from the generators, or to take excess power and store it for a later date.
Right. And I imagine this is something that is continuing to develop, and Lürssen is continuing to work on introducing new ideas to clients, and I imagine the technology is continually evolving.
Yeah, it has been. Like I said, Limitless was the first hybrid yacht. Lürssen also built the world's first fully diesel electric yacht, which was the motor yacht Ice, which is now called Air, or maybe I'm confusing. Maybe she was originally Ice and now she's called Air. But 90-meter Tim Haywood design, very, very well-known yacht. But that was with pods, and so that was that full system where you just had mechanical engines,
Right.
driving a generator, putting electricity into a system. Then that was taken through cables, through switchboards, to the electric motor that turned the propellers on the pods underneath the yacht.
Okay.
Now you see that more commonly
Right,
done again
right.
today.
Yep.
Generally, though, even though that is often discussed, generally there are inherent losses in the conversion of energy through the mechanical engine to the electricity to the generator, when it's transferred through the switchboard and through the electrical motor back into mechanical energy in the form of a propeller. That loss of efficiency isn't made up for until you get into very larger vessels. In terms of higher efficiency from other savings.
Okay.
So generally, you don't see pods in smaller vessels.
Right,
Only in the very larger vessels does it actually make theoretical
makes
sense.
sense.
Unless there's another reason, for navigational reasons or whatever, that you want pods.
And so the cost of doing that, kind of a two-part question, the cost of doing that is in a boat that size, eventually is that cost made up? Because obviously, as I would imagine, there's an additional cost to the installation of that.
Yes.
And do you get back to, I don't want to say net zero, but close to it, where you're making it up on not having those fuel costs? Or is it just more of a sustainability, having a greener, cleaner yacht? And also, maybe you can talk about the storage and the space needed for this type of technology versus your traditional.
Exactly.
combustion.
Yeah. So a full diesel electric system, or any version of hybrid, is almost always going to be more expensive to build than just a diesel mechanic system. And I have to say that if you look, even you're a very successful broker, so you've seen a lot of vessels. A diesel engine from 20 years ago compared to the diesel engines today, right, from MTU or from Caterpillar, the diesel engine today is way more efficient than it was 20 years ago.
Sure.
Diesel engines of today are actually pretty efficient and actually pretty clean. And sometimes that gets lost in all the rhetoric, is that, hey, I want to build a green yacht, so then I must have to have a full diesel electric system with pods.
Sure. Interesting.
Actually, you might find out that the pod is actually burning more, putting out more greenhouse gas emissions than actually a very efficient diesel engine, modern diesel engine that's the right size, with a mechanical propulsion, with a very good exhaust filtration system. It's the system we're the most familiar with, but actually, because there's been so many decades of R&D into it, it's actually pretty efficient, both in terms of fuel use, emissions, and power output. And it's most cost effective, because that's the most established system. As the more complex the system, inherently it's more expensive. And you also hit on a big one that's often missed. People talk about, hey, yeah, let's just put in a diesel electric system.
Right, not that simple.
Right, because what happens is if you think of a traditional yacht with a mechanical engine set up with a shaft, but you still have generators that have to create hotel load. And those generators are putting electricity in, and they have to go through switchboards, for all that electricity to be distributed throughout the yacht. The space on board a yacht for switchboards is something that we're all familiar with. When you start to put in the switchboards for converting all of the power created into electricity, so not just the power from the generators for the hotel load, but also the power from the generators from the main engines that have to go to the electrical engines, the amount of space for switchboards doubles and can even go more than double, triple. So it's a significant space given for just those switchboards, and those cost money. And then also, when you go into a full pod system, you have to remember that there has to be space allocated in that beach club area for the pod drives.
So it's something that needs to be done very early on in the design and build process. It's not something that we're going to change midway through. It's something that is thought of
early.
That's right.
That's right.
And off of that, how many of your customers that are coming inquiring, looking to build something, 80, 90 meters plus, or want to have some type of hybrid technology?
So the question is asked on almost every project, right? What's the best solution for this project? And so almost always we look at it, and we talk together with the owner, with the owner's team, if there's a captain involved, who can understand already the owner's profile, how they're going to use the yacht. Because of course there's the many factors. There's the space taken on board, there's the additional costs, but also there's the what's actually greener. And a big question that is asked also often is, how do I make sure I'm future-proofing this yacht? That I'm not building a yacht that in 10 years is going to already be limited in its operational scope or something along those lines. And so that question comes up a lot. And I think that often the quickest, shortest answer is, oh yeah, of course you should go fully diesel electric. But once you've gone through the full study, you'd be surprised that somewhere in the middle of the spectrum of options is where it's found half the time.
Right.
But sometimes it's just diesel mechanic is the best option, right? It's actually putting out fewer greenhouse gas emissions. It's more fuel efficient, and it's less complicated. And especially if you're in the 60 meter size range, it's space is really at a premium.
Right.
When the boat gets to 100 meters plus, space is always at a premium, but you have a little more margin to be able to fit in additional equipment.
And I suppose too that it might depend on how the potential owner is going to use the boat.
Absolutely.
Where he's going to go, what his expectation is, what type of boating he's going to do, how many miles he's going to put underneath the keel. I guess that would make a big difference in terms of what propulsion what would be best suited for him as well.
I mean, that's the biggest factor, right?
Yeah.
So we have one project where we've been looking at that is built for very serious offshore diving.
Okay.
And the boat would be able to hold its position in severe weather, huge seas, and rarely will it be intended to be at anchor, but even rarer will it ever intended to be in port.
Right.
So the idea is that the boat is always kind of dynamic positioning itself. And in that scenario,
it takes a lot of energy to do that.
right. And in that scenario, like a full pod system, it's also a larger vessel. So in that scenario, full pod system is the best choice.
Right.
But yet, on a 75 meter boat that we have coming in delivery soon, just a diesel mechanic system was the most fuel efficient. The profile, they're going to tow large tenders, which is very common amongst Americans. 75 meter yacht is a very large yacht. It's a beautiful yacht. It's for a guy or a family that is very active, but still. The fuel efficiency was at a premium with a diesel mechanic system. Yeah. So it just depends on the use case.
Yeah, I guess each scenario is going to be tailored to that owner's usage and what is going to end up being probably the most efficient, cost-effective way of building the boat.
That's right.
I don't know how many of our subscribers that are watching today are familiar with fuel cells. So can you break down exactly what are fuel cells and what that technology is leading into? Yeah.
So if you look at those versions of hybrid that we talked about already, from straight diesel mechanic, which isn't hybrid, to a PTO, PTI, to full diesel electric, a hybrid would be kind of the next step, and that's what we're now building. The world's first hybrid yacht. There's a couple other shipyards that have hybrid yachts. Fuel cell yachts built on a hybrid system, also in production. We've been working on fuel cell technology since 2009, together with several partners. Oldenburg is the sort of our lead partner that's developing the fuel cell system. We currently have a fuel cell that we've been talking about a lot in our shipyard. It's sort of our test fuel cell. So it's creating electricity that's being put into the shipyard to be able to learn how does it work in real life scenarios.
Yep.
And what a fuel cell is if you go for that full diesel electric system, right? So you have a system where the motors are electric, turning propellers. Obviously, the hotel load of the yacht is electric, and then there's a large battery system. What you need is if we wanted to replace the combustion engines, so the diesel engines, with something else to create electricity. In this scenario, we're replacing the diesel engines with fuel cells.
Okay.
So what a fuel cell does is creating electricity, which then fills batteries, which then moves the yacht and powers the yacht.
Okay.
So how does a fuel cell work? A fuel cell is basically a membrane. It's not that large. It's about this big, about double the size of your piece of paper there. And we pass hydrogen on one side of that membrane and oxygen on the other side. And as those hydrogen, oxygen combine to create water, electricity is produced.
Okay.
So we discharge the clean water, it's perfectly clean water, and we save the electricity, and that goes into the battery, and that fuels the yacht.
Wow.
So it's just combining hydrogen and oxygen. And the oxygen we just pull from air. Oxygen's all around us. So all you have to do is carry hydrogen on board. And hydrogen is a gaseous state.
Right.
So it's hard to carry hydrogen. But that is where the rubber hits the road.
Right. Yeah.
How do you carry hydrogen in enough of a quantity that it's useful? And how do you get really efficient at that little exchange of hydrogen and oxygen so that you're creating the optimal amount of electricity?
Right.
The first diesel engine, even once 20 years ago, used a lot more diesel to create the same amount of power. Right. Today, less diesel equals more power. So future fuel cells will be way more efficient than the ones we're using today.
Right.
So think about that fuel cell as one membrane. What we do is we get a whole stack of them. So they look like almost like a computer-like rack or stack. There's like a whole stack of fuel cells, and then you end up with a bunch of stacks. And so the first yachts will have like 16 stacks, and they're in their own little cells to keep them just sort of enclosed. But there's no moving parts, so it makes no noise, no vibration. The maintenance is almost nothing. Now the first ones, of course, we need to first prove this technology. So the first ones will be, but in theory, once this technology is proven and developed, it's way simplifying the whole system of the yacht. And yachts is where you see this technology being pioneered, because we have yacht owners who are willing to take big risks, pay more money for something that they don't need, right? If it doesn't work, then it's not like their cruise ship isn't working. But you'll see this technology then trickle down from us to military, to commercial, to cruise lines, whatever. But we're kind of, in a way, the test case, because we're able to spend more money and take bigger risks in a way.
And what a concept to undertake from an opening stance when a customer comes and says, we want to do this. I mean, I would imagine that the yacht is actually kind of built around this technology and the space that it needs, and how it's going to power everything, and then everything was just essentially built around it.
Yeah, I mean, because then one day we'll be able to say is, do we really need the engine room to be in the location it was before?
Right.
Do we need exhaust trunks like we had before?
Right.
We don't need that anymore, and that frees up the layout of the yacht considerably.
Yeah.
Now, on the first yacht that we just launched her hull just 2 weeks ago, is Project Cosmos, which is a really rad-looking boat. The boat itself is so cool. Right. Besides the fact that it has fuel cells, the yacht is built where half the power or half the engine room is still diesel generators. It has a full electric system, and the other half is fuel cells. And the reasons is kind of hedging risk, right?
Right.
So the yacht can fully operate on diesel, or could operate for up to 2,000 miles of cruising, or I think it's 20 days, somewhere around there, on just the fuel cells.
Just fuel cells.
And then in the future, once those fuel cells get more proven, we can remove more of those diesel generators. So it's made modular, so we can pull those generators out very easily through a door on the side and put in more fuel cells and extend the range.
Wow, so you could really actually change everything, even though the boat's
Make
a
it
few
full
years
fuel cell.
old. Yeah, that's interesting.
Yeah.
We've talked about some of the benefits. What are you think are some of the drawbacks of some of this new technology going into boats?
Well, fuel cells right now are so new.
Right.
So the drawback is, one, it's way more expensive because it's new, and so you're paying for kind of all the prototypes. Hopefully in 10 years, that price will come way down. The second of all is that it's just not proven, so you're taking a risk.
Right.
But the biggest at the moment is range, right? So as I alluded to before, we hope that the efficiency of the fuel cell itself improves significantly in the coming years as more of them are developed. So, and the other challenge is you can't carry very easily hydrogen on board a yacht.
Right.
Hydrogen is a gas.
Right.
It's explosive, or theoretically. So the catalyst that we are doing is, instead of carrying raw hydrogen in a gaseous state, it would be too big and not energy dense enough to carry in a tank. You could put it in a liquidized form, but you'd have to keep it at extreme cold temperatures and under high pressure, which is just takes so much energy to hold it there that you almost start going backwards in terms of the energy.
Right.
So we are carrying using green methanol, and green methanol has hydrogen in it, and we have what's called the methanol is the catalyst to carry the hydrogen, and we have a conversion process right before it goes to the fuel cell where we remove the hydrogen and apply it to the fuel cell right before the fuel cell.
Okay.
So the beauty thing of methanol is methanol at room temperature is a liquid. its combustion rate is very similar to gasoline or diesel.
Okay.
So we're able to store it in a normal tank in the bottom of the hull, like diesel with a double. Required to have double bottom tanks. But that's pretty normal for us. So it's that's the way we're carrying it, but it's just less energy dense. So methanol, the amount of energy in a gallon of methanol compared to the amount of energy in a gallon of diesel is around a little bit under half.
Okay.
So the same amount of fluid on board will only get you basically the half the range or half the, if that makes sense.
Yeah.
So that's a disadvantage.
Sure.
And we're hoping that in the future, we expect it as fuel cells go mainstream, they'll get way more efficient, and that'll change things.
Yeah, I mean, like you said, like the reliability, sustainability, what they're actually going to be able to do improve. You'll learn as you go. So based off that, how do you see the future? Is this? I mean, do you think this type of technology is here to stay in the yachting industry, and as it will continue to develop, it'll be implemented more and more, become more mainstream, and probably even work into smaller boats as well? I would imagine if it continues to be worthwhile. So how do you feel about the future of this type of technology?
I think absolutely. I think that you're spot on that it just takes a bit of pioneering from a shipyard and companies that are willing to put the investment in. Like I said, we've been investing into this technology since 2009. But then, and also some bold owners who are willing to take that risk.
Right, that's a huge
And
factor.
once it's out there and existing, more ships are ordered with it, more yachts are produced, the demand goes up, you have more competitors entering the market, not just shipyards, but actually more suppliers of fuel cells, right? And innovation then happens and the whole thing gets more efficient, more cost effective, and I think inevitably that will replace the combustion engine. The other thing we'd like to see is the increase in production of green methanol. Currently, you're able to bunker methanol pretty much around the world, but we'd like to see more green methanol versus just standard methanol.
Right.
And there is a lot of initiative here in the US and in the EU and in Japan for increasing green methanol production. But also just maybe other catalysts. Maybe someone will come up with a better way to carry hydrogen around. I mean, hydrogen is in the ocean water, so theoretically we could get it out and you wouldn't have to carry any fuel, but it would be hard to imagine that you can get a net positive out of that process of splitting it and putting it back together. I'm not sure if that's possible theoretically, but.
And I mean, you obviously, Lürssen is a pioneer in the large boat space, one of the pedigree builders, if not the pedigree builder in that space. But you are, as far as you know, are your competitors working on the same type of technology as well, or do you think you guys are set yourself apart from them? Do you think that they're in the same game as well?
Yes, I mean, look, there's always competition, and I think that's really good.
Of course.
We have two competitors that are currently building vessels that also have fuel cells, and one of them is taking a different approach than us. They're trying to carry actually hydrogen in the gaseous state on board.
Okay.
Of course, the deficit is that the amount of power they can get from that fuel cell plant is fairly limited because you can only carry so much gaseous hydrogen.
Sure.
The other one is maybe a couple years behind, and they're dealing in smaller vessels. We'll get to see what they do. Yeah. But honestly, I think it's not something that I'd like to see only Lürssen pioneer.
Healthy competition is going to afford the innovation and this process and the technology as well.
It'll be better for all of us, honestly.
Right.
We always encourage a healthy marketplace, and we don't want to see other good shipyards struggle or fall behind. We want the marketplace as well as a whole to do well.
Right.
So I think that the transition will happen across the board, and we welcome that.
It'll be interesting to see as the technology continues to grow, how it'll be implemented in different applications and into smaller boats as well.
Absolutely.
If you're getting into some production builders that are actually starting to use it or will try and use it at some point.
I mean, there's an major Italian builder that's publicly announced that they are intending to do that, and we encourage them. They've partnered with a German company on the technology side, so I fully expect that they'll figure it out, you know, and that'll be great.
Yeah.
And then eventually we'll see it even maybe make its way into even 50, 60 footers. Who knows?
Right.
If that happens.
If if that's the direction it's going to take.
What we see now on the hybrid side, let's say, is the full electric vessels coming up on like the small boats, right? The 20 and 30 footers. Just, of course, the problem there also is the range and the charging time. But that was the same issue with the early cars, right, as well, electric cars.
Right.
And that's finally become a less of an issue. So, you know, I think it would be somewhere along the lines where the vessel gets too big to be just charged on the shore and it needs to have its own plant. And that's where a fuel cell is a great solution.
Right.
So.
Well, great. That's been wonderful, Tim. Do you have anything else to add?
No, we're grateful to be here and that you came and talked to us about this. And we look forward to seeing the other videos that you make on the for the Engineering Week.
Yeah, I think it's going to be a handful of great segments. So that's it from us with Tim Hamilton, Director of Lürssen Americas at the Lürssen Americas office here in Fort Lauderdale Beach. Thanks you so much for tuning in and enjoy Yacht Engineering Week.
And that's a wrap for today. Yacht Engineering Week 2023 has been brought to you by our title sponsor, Pantropic Power, the local cat dealer, and our anchor sponsor, Robert Allen Law, the business of yachts. We would also like to thank our segment sponsors, Lürssen, Viking Marine Exhaust, Zemos, Marine Data Solutions, MPI, Bradford Marine, Dytech, Lewis Marine Supply, MPT, Tropic Ocean Airways, Ward's Marine Electric, Seabob, AquaBanas. We'll see you again tomorrow, 9:30 sharp.